Okay, let's get started. Uh, I just want to give a brief theory about LTSPICE. LTSPICE is a free program. It's a software developed by Analog Devices, and it's downloading and even installation. Everything you can do it. It is an open source type of software. Uh, it's basically an unlimited kind of the SPICE simulator, circuit simulator. Okay, SPICE we already know that. It's a program for integrated circuit emphasis simulation program for integrated circuit emphasis. That is the expansion of SPICE. And using this LT SPICE, okay, one can develop a circuit which we call schematic here. Schematic can be captured and you can simulate it, and also this can be used for waveform visualization. You can also see the waveform, just like in the cathode ray oscilloscope you observe input waveform and output waveform. Similar to that, you can visualize the waveform of the circuit, both input and output waveform, or both simultaneously. You can also see input output waveforms, just like in practical laboratory the way you do. And a similar kind of the platform will be provided by the LT SPICE. And this is basically used for analog circuits to simulate efficiently. You can check the performance of the circuit whether it is efficient or not, and this tool will provide the accurate simulation results. I don't want to go for more details. It is a graphical schematic editor. I keep doing it, and you also can start parallelly doing rigging up circuits at your place. Okay. And any questions if you have in between, you can also ask me, so that I can help you out in answering that. Okay. I'll go a little slow because meanwhile, since you are constructing circuit at your place, I don't want to go rush up and cover everything. In today's class we only cover LT SPICE, and the next class we'll take up the IIT Kharagpur, the basic electronics virtual lab simulation. Okay, so this is the window after the installation. I hope have you got this type of window?
Yes, sir.
All right, then the first thing is you just go through the pull down menus. Any software, just look at the various pull down menus. There is a scope for new schematic here. Just observe it. That's all. Don't no need to do anything. And you can also create a new symbol of your own. That is possible. And you can open the existing LT SPICE, the file, schematic file, and you can also check inbuilt examples. You can also open those examples and you can see. You can also take up the print of whatever you capture here. That can be print, can be taken. That is in the file menu what you are observing. All these are the pull down menus of file section. Then comes view. If a few things are not enabled, I suggest you to enable toolbar, status bar, window tabs, everything. Okay, so in the view menu. Then comes the tools. In the tools there is a setting, color preference, and update components. You will see that later on uh, color preference, how to do it for the visualization window, and color preference for the circuit rig up window. All those things you can do it in the color preference section. Okay, and you can also update the components of LT SPICE if you connect your system to the internet, and if you just ask it to update, it will update with inbuilt latest the components available in the LT SPICE. Okay, and there's a help menu also. You can go through the help menu, and also you can see that you can also see the model change log and the LT SPICE change log, all these things, whatever the updates log updates you can see there. And you can also see, if you click on this it will take time, but there is an option called check for LT SPICE updates. In case if you have installed long back the software, right now you can just click on that. If you have installed today, nothing to worry about it, because you will be installed with the latest LT SPICE components. This is only for the students who installed software long back. If you want to update it, you can do that. Okay, so these are the various the pull down menus. You can go through them, okay, one by one. So important thing is once we rig up circuit, you will get to know what are the important and necessary kind of things. Now what I do is parallelly you can do, okay, as I keep doing it, you just click on the new schematic. Once it is done, you can just update me. you will get this kind of window. Just there's a plus symbol here, just you can click, single click, right click, you can left click, you can do it, so that a window will be opened here. You can see the screen. I just clicked this plus button, or you can also go for new schematic and you can click that, you will get a window like this. If you're done with that, let me proceed further.
Yeah,
Now,
I've done so.
yes. Now you can see that few pull down menus, the toolbars were not enabled earlier. Now you can see various toolbars. Are you able to see the toolbars above?
Yeah.
Yes, sir.
There is, I will just go one by one. There's a configuration analysis. There's basic things I will leave it, like save, print, all those things. Configuration analysis is there, which we may not use frequently, rarely we use it. And this is a run. When you want to run the schematic circuit, you can click on this. We will see that when to use that one. And halting, if the simulation keeps running, you can halt. Okay, once this is enabled simulation, then later you can halt it using this halt uh, button icon. And there is even shortcuts also, alt plus yes, if you just press together, simulation can be stopped. And you can also arrange the windows, vertically, or you can go for a horizontal window arrangement, or you can even cascade windows also. If you're doing multiple circuit simulation, you can cascade windows in this window what you are seeing. Okay, then there is a zooming option, and even this is going to be the zoom back. And certain portion can be zoomed to fit if you want to see, observe any specific area. And we have a wire here to connect different component that you place on the window here. And there's an again ground here, you can see ground. Most of the times we need a ground for the circuit. Okay, and there's a voltage source, we need a DC voltage source, we need AC voltage source, especially for rectifier circuits we use AC voltage source. For simulating voltage current characteristics of PN junction, we use just ordinary DC voltage source, a variable DC voltage source. And there's a resistance here, okay, which you can just have different values, capacitor. These are symbols, that's all, icons. Just if you drag it, you can change the value, whichever value you want it. Okay, and there's again inductor, there is a diode, and there's a component. If any component, if you want to get it, you can do that here. And there's a net here, label net. We'll use this label net in our circuit simulation. That is again text here. And some directives, some diodes, some components, if they're not available, you can get it through the writing the command here, called as spice directive. I'll show the couple of directive, how to use it. And if you want to delete any diode component or even any circuit, you can do that here. And you can even duplicate the components using this icon. And you can even move the components using this icon, move mode, it is there. And even a stretch mode also we have available, it's there available in the pull down menu. I hope all these things, you are familiar with this. Any questions regarding the pull down menus, or the list, which is a toolbar list given here?
No, sir.
All right, so these are only basic things. So whatever I covered. Now let us start with the specific circuit called voltage current characteristics of PN junction. Okay, you already studied the voltage in theory, the voltage current characteristics. Now let us construct same circuit here and show the voltage current characteristics. First and foremost is, here we have uh, a springboard like structure here. You can place all the components first before you do any connection. So now for rigging up, for obtaining the voltage current characteristics of a PN junction, what we need is first the diode. Let me bring the diode here. I will click on this. Meanwhile, you can also do this. Just left click on this. If you do this, you can see that already diode is available to you. I hope you can see the diode now. In your also, just left click on the board and bring it other side. Other diode also it's available. So if you want to come out from this, you can just right click, or you can press escape. Hope you have followed. Just click on the diode symbol and bring it to the this icon, springboard icon, and then place it again. Left click, and if you keep moving away, another diode will appear. To get rid of it, just press escape or right click. Hope you're done with this. Is anybody any doubts you're getting here to place the component? I hope you have placed the PN junction vertically downward. You can rotate also, but here it's not required. Later on, I will show you how to rotate it. Next component is going to be the resistor. Resistor. Now, what you do is before you place it, before you click here, just you have to rotate it. For that rotation, you have to press, Control plus K plus R. Simultaneously, you should press. I'm pressing it right now. You can see all together. Control K R. Control K R. Now you can see it has rotated. So it still have not placed on the board. I'll just do the left click. It will get placed on the board. I will just click left click. Another resistor is available. I don't want it. I'll just do the right click. It will disappear. If you have placed any component wrongly, you can also do deletion here. You can see the delete mode is there. Just you can bring it here. See, cut it. It will get deleted. Okay. I'll do once again for you. I'll take resistor. Click on that. It's appearing vertically downward. To rotate this, what I do is I press Control K R simultaneously. Now you can see here resistor is available. I will place wherever I want it. And then one more resistor is when I scroll up, move next to the resistor, another resistor is available. To come out from this, I will just do the right click. Hope you have done this.
Yes, sir.
Is there any difficulty you are facing at your side?
No, sir.
Okay, all right then. So we have placed the diode, we have placed the resistor. Now I want voltage source. You can see here, I will just move my mouse to the voltage source cursor. Can you see there voltage source V?
Yes, sir.
Click on that. Same procedure again. Bring it, place it by doing a left click. To come out from this, do the right click. Left click to place, right click to get, avoiding another one, another voltage source. If you're done with this, let me proceed further.
Yes, sir.
Next is we need the ground here. Just go scroll it here. I'm just moving to the icon where it is showing the ground. Just again do the same left click. And again one more left click. Wherever you want, you can place it. For placing, you can do the left click. And then I'm getting another ground. I don't want it. I will do right click or press escape to come out from this. Okay. So done.
Yes, sir.
Okay. I think all the components, required components we have placed here. So now it is doing a connection, wired connection now. Now you can see there is a wire here. Again, same procedure. Left click on the wire. So wire is now available. Now you have to click where the node is there, V1 node. Start from the voltage source. Just do left click here. Extend. One more left click. I will do the right turn. Again, do left click. I have done the connection. Voltage source to resistor connection I have completed. Just two clicks. One at the voltage source, another click, another in between to turn the wire, and again one more at the resistor side. If you could not follow, I will do one more time for resistor. You can see that other side of the resistor. I will do here where there is a blue icon here at the end of resistor right side. I will do click here, and now see here I am just moving my mouse and I just want to go down. I will click again here and go down, and there's another blue color diode. I'm seeing it. I will do one more left click. In the same way, you can follow for cathode of diode to voltage source. Again, I will do one click here, left click. I just want to bend here, wire. Click one more, left click, bend, then voltage source. Loop is completed. And finally, I will place one more to the ground. I'll again click on the ground wire to the node, to the wire which is connecting voltage source and diode. If you are done, you can inform me so that I can proceed further. At this stage, I think we have done the connection. First step, we placed components, that is the number one. In the second step, we just connected all the components, that is the step two. Step three is providing values to each and every component. Any difficulty at your level?
No, sir.
Okay. If you're done with this, then let us go for changing the component values. To change component values, what you do is first to start with the voltage source. Just right click on the voltage source. You can see that there is a DC value. You can just type here 5 volts or simply 5, DC value as 5. Then say OK. All of you understood what I did here? I just right clicked on the voltage source and I entered a value of 5 volts as a DC value, and later I'm clicking on OK. In the same way, I will right click on the resistor, and here below you can see resistance. I'll just enter here 1K. Resistance as 1K. Then you can say OK. I've completed giving voltage to the circuit, 5 volts DC voltage. Resistance value has changed to 1K. Now I will move to the diode. Right click here, diode. Once you do right click on the diode, you can select the whichever diode you want it. For that, you need to click on the pick new diode. So many diodes are available here. If you want specifically diode called 1N4001, you need to include that as a model. But right now, the diode, let me check whether 1N4001 is available or not. You can see here 1N4007 is available. Last, it's available. You can just click on this, and this has got very large breakdown voltage, 1000 volts breakdown voltage, as it is shown here. Or else you can even prefer this very beginning. There is 1N4148 also, because this has got very less breakdown voltage, 75 volts. In the very beginning, there is a diode called 1N4148. Okay, silicon diode it is, and its breakdown voltage is 75 volts. And the SPICE model is also shown here. You can see this is the SPICE model. In case if you are unable to find any diode in this list, you can write a model, SPICE model like this, and add to the circuit. Anyway, right now to do simulation, I prefer this 1N4148 and then say OK. You can see that immediately when I did, the diode has changed to 1N4148. Any doubts, any questions?
No.
So is it your circuit same as my circuit which I have shown here?
Yes, sir.
Sir, is it possible to reorder the position, reposition the components?
You mean you want to move the resistance or what you want to do?
I want to move the diode a little upper.
In such case, you delete it and add new one. No?
Oh,
Or you
okay.
can also enable move here. There's a move option. You can see that. You can click on that and you can move this. Suppose if I will click on this one, just see here, I can move wherever I want it. Here. Suppose if I place here, I'll just right click and I will do one more connection here to the wire. Look at here. This is a wire. I'll click here, and I will click here again, click here, and I'll remove these unwanted wires by clicking here. See? This one, this one. Right click, it will disappear. It's user friendly. Can you do that? There's an into mark which you can delete the component also. You can place new component. Any number of times you can place new component. That is not a problem. Okay, is it clear? Any others have any doubt? If you are facing any problem, you can just ask me so that I can help you in the construction of circuit.
No, sir. No problem.
Okay, I think now your circuit is ready for simulation. Circuit is complete.
Yes, sir.
Yeah. Now let me do simulation. Before you do simulation, what you do is just click on the simulate. Follow this instruction carefully. Click simulation. Why I'm doing this, I will tell you that. Here the voltage source that we have given is fixed to 5 volts, right? Okay. So I want to make this voltage as a variable, correct? Because then only I can plot the diode characteristics. Okay. To make this voltage variable, what you can do is just go to simulate, and there is a configure analysis. Can you find this one icon?
Yes, sir.
Just click on that configure analysis. Are you able to get the window like what you are seeing on my screen?
Yes, sir.
Everybody got any problem in getting this window?
Yes, sir. We got it.
Now you have to click on here. So many analysis we have: transient, AC analysis, DC sweep, noise, DC transfer. So many things are there. Okay, so now you can go to the DC sweep. Okay, in the DC sweep, you can see there are three sources are there, which the tool has provided us. First voltage source. In this circuit, we have only one voltage source. In case if you have a second voltage source or third voltage source, the value can be changed, and you can give a different value, a variable voltage to different voltage source. But since here we have only one voltage source, and what is the name of first voltage source? It is a V1. Just type here V1. Name of first source to sweep V1. Okay. If you're done,
Yes, sir.
next is the type of sweep. It should be linear. Click on that icon. You have to select linear in that. Once you do select linear, then here we have to plot both forward and the reverse characteristics. Therefore, I suggest you to start with minus 5, minus 5 volts negative, and stop value is plus 5 volts. Just simply you can give 5, and you can give increment of voltage as 0.01. Just see this. If you're able to enter these values, name of first voltage source to sweep is V1. As you can see here, there is a V1 here, and this sweep is going to be linear. Linearly, we are increasing the voltage. Starting value of voltage is minus 5 volts. Stop value of the voltage is plus 5 volts. Increment is going to be 0.01 volts. Hope you have done this one. Any difficulty in entering the values?
No, sir.
If you're able to enter these values, then you can say click OK. When you click OK, you can see that with my cursor, these values are appearing, right? You can just place away from here. You can just place it by left clicking here. Okay. Any problems?
No, sir.
Let me tell you what you have done so far. This voltage source earlier we have given as a 5 volt. I made this voltage source as a variable. It's a DC voltage. Now V1 starts from minus 5 volts, stops at plus 5 volts, and value gets increment at the rate of 0.01 volt. That is what we have given condition for this voltage source. Now we are almost ready to simulate this circuit. If everything is okay at your end, then we can go and simulate this circuit. You can move circuit wherever you want. See that how user friendly it is. You can move. Just to click this, you can move. You can even zoom it and zoom out. See, if you do a cursor, you can see that you can zoom out like this. Done. Please keep doing. I will just type the instructions so far what we have given, and just to use word icon to. So let me type the instructions so far what we have done. Step 1 is place components from the toolbar. Place components on the virtual board from the toolbar. This is what first step you did. Step 2 is to go to the software. After placing the component, then we did the wiring, wire all the components. Okay, every component should get connected. First we have taken the voltage source, resistor, diode, ground. Then later we connected all these things. Step 3 is provide value to the all the components. Example, voltage source V1 we provided with 5 volts. Resistor we have provided with the 1K value. Diode, the diode which we have chosen is 1N4148. 4148. Okay, I'll just write even components what you have. We have a voltage source as V1. We have a resistor as R, and we have a diode. Then we have a ground. Okay, using the wire, we have wired all the components. Then we provide value to all the components. V1 as 5 volts, R as R1, not R, it is R1 as 5K. Diode is 1N4148. Once you make connections, what are the next step we did? We made a voltage source as variable. The DC voltage source is made as a variable. How did we do that? Just we have right clicked, not here. We went to simulate, configure analysis. So here we did change. And write it here once again. We have gone for simulate. In that we have configure analysis. We clicked on this. Then in that we have gone to DC sweep. Then we gave name of voltage source. Voltage source we are given as V1. Okay. Name of first source. There are 3 sources as you have seen. Name of first voltage source is given as V1. And next is type of sweep. Those are many icons are there. We said that it is a linear. Next comes start value. We give -5 volts. Stop value we give +5 volts or simply 5 volts. Even if you write simply number also, voltage is not required. You can also give simply number. Increment, at what level this has to be incremented? It is 0.01 volts. Okay, to obtain both this minus and plus 5 volts what we are given is to obtain -5 volts to +5 volts is to obtain both forward and reverse characteristics. Okay, I'll just highlight here all steps. I'll share this with you so that you can follow these steps, and this remains same for most of the circuits. Okay, any doubt, any questions before we do run the simulation? Do you have any problem?
No, sir.
Okay, if you're done with this, let me now go for run here. There's a green icon. Can you see the green icon here?
Yes, sir.
Just click on that. And what did you get? You can tell me after clicking this. What was the output when you click on the run icon?
So we got a black blank screen. That's it.
I'll click on mine one. You can see now. Are you able to get same as my window?
Yes, sir.
Observe the x-axis here.
Yes, sir. It's the same.
Can you observe x-axis now? Can you see the x-axis now?
Yes, sir.
It starts with -5 volts and ends with +5 volts. Okay. Now you can right click on the window. Just see here my cursor where it is. On the block window, just do right click. What did you get when you do right click? You must have got the form like this.
Yes, sir.
On the block window, if you do right click, you will get a form like this. And there's an icon called add traces. Can you identify? Can you locate that? Add traces. Are you able to find the add traces?
Yes, sir.
Then click on that, add traces. Left click on that. You will get another window. Can you get all these values? V1, V of N001, V of N002, I of D1, I of R1, I of V1, all these things?
Yes, sir.
Then you're right. You are on track. Okay. If you are getting all these things, then circuit is correct. Everything is perfect. Now here you need to select I of D1. Just to do selection of I of D1. Have you done that? Selection of I of D1.
Yes, sir.
Click OK now after doing that. Can you get the curve what you are seeing on my screen?
Yes, sir.
Everybody? Now I want to ask you a question now. Is it forward characteristics or reverse characteristics we have plotted here? Is it looks like the waveform, does it looks like a forward and reverse characteristics of a diode?
Yes, sir. Yes, sir.
See, exactly if you look at VI characteristics, it looks like a linear, but not like our diode characteristics. We'll try to bring it to the diode characteristic by doing some small change. Okay. Because here we have plotted the source voltage itself on the x-axis, right?
Yes, sir.
-5 volts to +5 volts. The input source what we have given, that is our x-axis. But what was supposed to be on the x-axis? Not this voltage.
Current.
It's the voltage of the diode across diode, right?
Yes, yes.
So it has to be voltage across diode. That should be on the x-axis, right? Okay. Voltage at the diode should not exceed what? 0.7 volts if it is silicon diode. Correct? How do we get now? For that, I will show you a few steps here. Okay. Now you need to find here in the pull down icon what is called as label net. Can you locate label net here? See, my cursor is showing there label net. Can you find that label net? I'm showing in the pull down menu, you can see there label net. If you have identified label net, just left click on that. Once you do left click, you will get a window like this. Okay. If you're able to get this, I will move forward. Just after getting this waveform and circuit below, what I suggest you is now just click on the label net. Reason I will tell you why we are doing this, because x-axis is going to be the DC voltage source. Here we want to make the voltage across diode. For that, I'm just clicking on the label net. Left click on the label net. Here you type V naught. You can type capital V naught or small V naught, whatever. It doesn't matter. Have you done that?
So can you repeat once again?
Yes. See, if you are able to see this waveform window and the circuit window simultaneously, then you are perfect. Till this stage, you are okay. Now, just click on the label net. Left click on the label net. Can you locate the label net in the pull down menu? There is net written here. You can see there.
Yes, sir.
Just left click on that, you will get a window. Another window will pop up. There you type. There's a space where you can type there as a capital V O, V naught. If you have done this entry, then press OK. If you press OK, in your cursor, a V naught will appear. Just place between R1 and D1. And to come out from this, type right click. Do you want me to do again?
No, sir.
Could you able to place this V naught in between the resistance and the diode?
Yes, sir.
Yes, once you've done that, to overcome that, you just press escape or do the right click. Another V naught, it's not required. Done, everybody?
Yes, sir.
If you're done with this, then you're all right. Then go to the run and click that run. So nothing can be seen, just click that run. You run again. Done.
Yes, sir.
Okay, if you're done with this, then go to the x-axis here. Look at where my cursor is there. I'm just moving to the x-axis. My cursor, I'm moving to the x-axis. Before that, is it clear to you, all of you? Any doubts you have at your level?
No,
Till
sir.
till this, is it clear to you?
Yes, sir.
Okay. Now after placing this V naught, have you pressed this run again? Run icon again. After placing V naught, just click the run icon again. You won't see any change. If you're there with me, then I can proceed further. Any problem from your side?
No, sir.
Okay. If you're already done till this stage, let me now proceed further. Now on the this waveform window, just do right click. Again, you will see add traces. Just do right click on the waveform window. Have you done that?
Yes, sir.
Then go to add traces. Have you gone to add traces?
Yes, sir.
Now you select here V of V naught. Just select, don't press OK. Just select it. Could you able to see V of V naught? First icon, first entry.
Yes, sir.
Just select that. Then you below you can see same thing. You can copy that V of V naught. Just do copy. I have copied that V of V naught.
Yes, sir.
After selecting, below it appears in the expressions to add. There it appears same. You just do right click and copy it. Then you close it. Don't press OK. Close it. Have you done this? Copying
Yes.
is done. Then close it. Don't press OK. Then come to the x-axis. Look at now x-axis where my cursor is there. Right click on the x-axis. You can see one more window, horizontal axis window. Could you get the horizontal axis window?
Yes, sir.
Now you go for quantity plotted. Paste it over there. Instead of V1, paste it as V of V0, whatever you copied. I am just changing x-axis to the V of V0. That's all. Nothing else I am doing it. I'm just replacing voltage source with the voltage across diode. Can you able to paste it in the space provided as quantity plotted?
Yes, sir.
Now press OK. Now you can see This is diode characteristics. Could you able to get the diode characteristics?
Yes, sir.
So I think we have completed this diode, plotting diode characteristics. Any problems you have come across? Please let me know before we do some analysis on this. And look at our forward characteristics. Voltage across diode is not crossing 0.7 volt. Are you seeing it here?
Yes, sir.
From 0 you can observe it. Up to 0.7 you can see that once it is going towards 0.7 you can see that exponential increase in a current. The y-axis shows the current, and x-axis you can see that up to 0.7, no, once it is close to 0.5, 0.6 you can see there's exponential increase in the current. And you can see the reverse characteristics. See, we have shown up to 5 volts, minus 5 volts here, but the diode breakdown voltage is 75 volts, right? So after 75 you can see the knee region in the diode, but here we have limited to uh, minus 5. But again, observe negative voltage, the current is close to the 0 only, because it is due to the minority carriers. Any questions?
No, sir.
So now can you, yeah,
Question. What is the that work of that NAT tool exactly?
what is the
Function of that NAT tool exactly?
NAC tool?
Yes, sir.
This tool, your LTSPICE you are asking?
Yes, yes, sir.
LTSPICE is basically circuit simulator. Like this, you can just rig up a circuit and simulate and see the waveform.
No, sir. That the tool that we used earlier, that NAT over the toolbar.
Okay, net, you are asking net.
Yes, sir.
Net is basically the this simulation that you are asking, or what? I'll just stop it here. Wait 1 minute. I'll just close this. I'll just make it bigger. This net you are asking, right?
Yes, sir. This one.
What we you see, this is a net to create this additional output voltage. I want to measure a voltage across diode, no?
Yes, sir.
Our graph is what? It is a voltage across diode versus the current, right? Current flowing through the diode. That is what VI characteristics, no?
Yes, sir.
Since earlier this was actually x-axis.
Yes, sir.
I'll just do roughly. You can see now. See, I will delete it this V naught, and you can see what kind of graph you get it. I have deleted V naught. I'm not going through the net now. Okay, now you observe it. I'll just simulate this one. Okay, I'll just save it and simulate. Now look at here. So what I do here is now I'll go for right click and add traces, and I will plot the current along the y-axis. IFD1 is the current along the y-axis. Now see what kind of graph you got it now. Just observe it. X-axis is the voltage source V1, varying from minus 5 to plus 5. Okay.
Yes, sir.
And we want actually voltage across diode, not the input source.
Yes, sir.
For that, I want to place here one voltage source, the output voltage, no? And I want to plot that my x-axis has to be the V0, not this V1.
Yes, sir.
So what I do for that is I will go for net. This is what I did. And later on what I did is I have typed here some label for the output voltage, say VO, some label I have given, and I will say OK to this. And where I am placing this, it's very important. I am not placing here again. If I place here again, you get same curve. I am placing between R1 and diode. I will place here and come out from this. This is V naught. So V naught is a net. Net means it is a wire. Some output measurement wire. The voltage I have given as a label name as a net V naught. And now I want to plot a graph of V naught versus current flowing through this. Current is already plotted. You can see here. IFD1 is already plotted. IFD1 is shown along the y-axis. But problem is with the x-axis. Instead of this voltage source, we want to replace with the V naught now. How do you do that? For that, again, you have to go to the waveform window, right click on this, add traces. I just missed it one step. I just want to run it here again. After making here placing V naught, I have to run it. Then I will go to the waveform window, add traces. Now you can see V of V naught is available here. I will copy this and add to the x-axis. I will not say OK to this. Close this. Now I will go to the x-axis. I will right click on the x-axis. Now it is a V1 exists. V1 is nothing but input voltage source exists. I want to make it as a output voltage source. I mean voltage across diode. The moment I say OK, you can see diode characteristics. It is a voltage across diode is along x-axis and the current is along the y-axis. Did you understand the significance of net?
Yes, sir.
Okay. Any questions you have?
No, sir.
Okay. I hope you are cleared with this diode characteristics. Can we go for one more, or is it? You want me to end up? Shall I show Zener diode?
Yes, sir.
I will do it. You just observe it. Don't do anything. Later on, you can do it after looking, going through my procedure. Okay.
Okay, sir.
Okay. Now I will close this diode experiment. I think a diode is this much. We have plotted the forward characteristics because this diode has got a breakdown voltage of 75 volts. That's why you are unable to see the complete knee region in the reverse characteristics. Okay. Now what I will do is I will go for Zener diode characteristics to plot the Zener diode characteristics. Okay. So I will close this one. Okay. Save it and go for new one, new schematic. So this is a new schematic. First step, you can see that what I'm doing here. I will just place all the components. You keep telling me now what are the components I need to plot the Zener diode characteristics. Voltage source. I have clicked on the voltage source. I have placed on the virtual springboard and right click, that disappear. Next, I will bring the resistor. To rotate, I need to press Ctrl plus K plus R. Rotated. I have placed resistance. Right click to come out from that. So voltage source is there, resistance is there. Next, I will go for diode. Later, I will change to Zener diode. Initially, I am placing diode here. Again, right click, left click, and then right click to make it disappear. Then I will go and get the ground. I'll take ground, left click, place ground, and to overcome from this another ground, you will just right click it. Exactly similar to a normal diode characteristics only, but let us see that what change I need to make it here. I placed all the components first. This is the first step. Next step is I want to connect all the components. I will go to the wire, connect from V1 to resistance, from R1 to diode. Here I want to bend. I will click one more left click, then diode D1, from diode to voltage source, and now from ground I will connect it to the wire. So circuit connection is done. Any doubt till this step?
No, sir.
You have done already the same procedure. I'm repeating it, that's all. But here I'm going to plot for Zener diode characteristics. Once you place all the components, next thing is providing value to each and every component here. Okay. So what I do here is just right click here, and you can give some voltage here. Later on you can change to, I'll go for this one, DC sweep. Later on I will give this value instead of providing this value here itself. And this value I will make it as 1K, 1K same. Next here, just right click here. I want to pick a new diode, but now I will prefer the Zener diode. I'll go for a specific Zener diode which starts with E. Just let me identify the Zener diode here in the list. So Zener diode starts with EDZ, something like that. I will just prefer that Zener diode. Yeah, EDZ, you can see that I will prefer this one. Look down, look up here, look here. This is EDZ V6 underscore 2B. This is the number, commercial part number. Okay, and it is Zener diode. Breakdown voltage is 6.2 volts. Okay, I will just say OK to that. You can see that now immediately diode has been changed to Zener diode. Are you seeing it now?
Yes.
So now this is, I'm plotting the Zener diode characteristics. Therefore, I have changed to Zener diode. Here I will change V1 to 5 volts. Later on, I will make this as a sweep to a bigger range. Okay. Initially, I will make DC voltage 5 volts. V1 as 5 volts. Is it clear to you, all of you?
Yes, sir.
Do you find any difficulty in this one now? So just placing components and changing its value, that's all, after doing the connection. Next, what I will do is now, I'll go to the simulate, and now what should I make now is, this voltage, I have to vary. I can't vary this because this Zener diode has got cut-in voltage of 6 volts, right? 6.2. So therefore, what I do is I will vary this voltage from minus 10 to plus 10. For that, what you do is go to simulate, configure analysis, just like earlier we did for DC sweep. No, same thing you are supposed to do here. Now here we have a DC sweep, and the name of the first voltage source is V1. And just look at here, this is V1. And type of sweep, what we are given earlier, same sweep you should do it here also. Linear sweep. And here voltage is minus 10. Why I have given minus 10, you must be aware right now. Because Zener breakdown happens at 6 volts, right? So I'm starting from minus 10. You can see now knee region, everything in this Zener diode characteristics. Then I will go for plus 10 and increment in steps of 0.02. Do you have any doubt here?
No, sir.
So I'll read out here. Voltage source I have taken as V1, and I made this as a linearly varying voltage source, which starts from minus 10 volts stops at plus 10 volts, and increments at 0.02. Once we have done this one, you can say okay. Now I can place somewhere here. Now I made this, how this voltage source has to vary. It has to vary like this. It's a DC voltage source. V1 is varying from minus 10 to plus 10 in increment of 0.02. Okay. So now we have defined the voltage source, we have defined the resistance, and we have defined the Zener diode. Okay, next is I have to run it. I'll just run it. You can see that you cannot see anything here, but look at our x-axis first. It's varying from minus 10 volts to all the way up to 10 volts. Correct? Okay.
Yes, sir.
Now what you do is to get the graph here, just right click on the waveform window. I did that. Now I need to go for add traces. Just left click on add traces. Now you can see there, I want to plot current along the y-axis. I of D1 is the current along the y-axis. And just move here, you can see that D1. What is the current flowing here? That is our y-axis. I have selected I of D1 y-axis and say OK to this. Look at now. You're getting both reverse characteristics and forward characteristics, but not exactly similar to Zener diode. The small changes we need to do here. Is it clear till this stage?
Yes, sir.
Any questions here?
No, sir.
Okay. Now here, as you remember that previously what we did to get accurate characteristics?
Yes, sir.
Can you repeat me what we did earlier?
We use the net tool.
Yes, we used the net tool and placed in between R1 and D1, and later we added to the x-axis. That's what we did, no? Okay.
Yes, sir.
Let's do same thing now. Even now, I'll go to the net. Next, what we should type here? VO, that is the output voltage. Okay. Then what should I say? OK to this. And where should I place this one? Between R1 and D1.
D1.
I placed it. And another copy is available. I will just get rid of it. Done. Okay. This part is it clear to you?
Yes, sir.
Now what should I do? I should run now. Correct? I should
Yes,
run
sir.
again. I run. Next, what should you do? You should right click on the waveform window. Again, go to add traces. Now you can see V of V0. You just copy this. Don't do anything. Close it. Now my x-axis, I'm going to the x-axis and right click on that. Now I will change to V of V0 and say OK. Now see now. You got Zener characteristics, right? Perfect Zener characteristics.
Yes, sir.
Both you can see forward and reverse characteristics. And breakdown voltage, you can see that close to 6, there is a breakdown is happening, right? X-axis, you can observe it. At 6 volts, very close to that, the breakdown is happening. You can see the reverse characteristics. Okay, and just zoom it here. You can see the reverse characteristics. See? Okay. Maybe 6.2, somewhere 6.19 or 6.18. Here itself, the breakdown, 17, it started breakdown. And 1819, we can see that breakdown is happening. This is Zener diode characteristics. I'll just go and zoom to fit. You can see now forward characteristics also. Yeah, you can see that 0.72. Again, same as ordinary PN junction diode. Okay. Now if I change resistance, do you think characteristics will change?
But in this case, the forward bias, it is reaching around 0.8 volt.
You can zoom it and see very close to uh, this region. You can see at 720 itself, zero point 0.7 itself, it started increasing.
Yes, sir.
You just zoom it and see, you will get complete accurate characteristics because these are built on models. Okay, this is accurate than the practical diode characteristics which you obtain by plotting, by taking reading in the laboratory. Okay, this provides us in exact characteristics. Probably when you plot, go to the laboratory and construct circuit like this and have a measuring instrument across this voltage measuring instrument and the current flowing through this. If you plot, you may not get exact curve like this. There will be deviations in the practical graph of voltage current characteristics, but this is accurate. It is providing. Generally, cut-in voltage of a diode or threshold, what we call, it will be zero point 0.7 to 0.75. That range. Depends on type of diode. This is Zener diode now. If you have asked me to show the diode like 1N400, okay, 1N400, that is actually ordinary PN junction diode. You may see very close to zero point 0.7, but this is a Zener diode whose breakdown is at 6 volts, 6.1 or 6.2. That region breakdown happens. And the forward characteristics, it depends on. You should go through the data sheet of this. You will get to know what exactly the forward uh, barrier voltage. Okay. Now I will change resistance and see whether the characteristics changes or not. Instead of making this as a 1K, I will make it as 5K. Just observe the characteristics. Okay. Do you see any changes? I don't think so.
No, sir.
That means changing the resistor value doesn't change the characteristics here. Understood? That is what the conclusion we are making here. Okay. This is just a current limiting resistor, no? Only to
Yes,
limit
sir.
the current. This is sensitive whenever there's a big change in the current. Otherwise, this doesn't make any sense on the characteristics, whether forward characteristics or reverse characteristics. Okay. Kindly practice all these things what we have explained in today's class, and next class we will demonstrate even rectifier circuit, both half wave and full wave rectifier circuit. You will get clarity on the usage of LT-SPICE. LT-SPICE is again it's a freeware and unlimited, and you can construct any circuit without any node limitations, and you can also verify the answer and verify the results characteristics using by rigging up the circuits. Okay, so in the next class we will cover up the rectifier and both half wave rectifier and full wave rectifier. And in today's class, I hope you understood how to construct and simulate circuits of half wave. I mean the PN junction forward and reverse characteristics and Zener diode forward and reverse characteristics. Okay, that's all for today, and let me continue in the next class. Okay, thank you all for watching this.